As always, let's leverage DevNet sandboxes for our testing. GlobalMantix uses DHCP in production, so let's grab a list of DHCP pools to start. I'm at the iOS XE Always On sandbox page. The instructions provide the hostname and login credentials, along with the custom TCP port of 9443 we should use. I'm using the latest sandbox to demonstrate the newest code. Let's go to the shell. First, we will explore a script that collects existing DHCP pools. We are going to use the trusty requests library to interact with the device via HTTP. These first 3 lines of code should look familiar. I recommend disabling any SSL certificate validity issues when experimenting. Also, we define the base API path, which provides a single location to modify the hostname if it changes. Last, I copy the DevNet credentials into a 2-tuple for HTTP basic auth. We want to receive Yang data encoded in JSON, so the accept header communicates this to the router. We issue an HTTP GET request to the native /IP/DHCP/pool URL. From the previous clip, I pointed out how this URL is derived based on the Yang model hierarchy. We pass in our standard requests parameter containing headers, authentication credentials, and our desire to disable SSL certificate checks. This debugging line can reveal the JSON structure that comes back, and we'll explore an example of that next. Similar to netconf, this data is Yang structured except uses JSON encoding. I added this DHCP pool to the sandbox before the demo just so we have something to look at. The ID is the name of the pool, and we see IP addresses represented as strings for the default router, DNS servers, and network attributes. Now that we understand the JSON structure, we can display it in a user-friendly format. The HTTP response will be 200 if at least one DHCP pool is configured. We parse JSON from the body and reference the Cisco iOS XE DHCP :pool key. This identifies the Yang model and the feature. This is a list of dictionaries, so we iterate over it using a for loop. These basic print statements just pick out individual values and display them. Using some simple nested loops, we print out the default gateways and DNS servers since there could be many entries. If there were no DHCP pools, the HTTP response would return code 204, which is a successful code but means no content. We print a simple message telling the user that no pools were found. Let's run the script and examine the output. As expected, we see one DHCP pool representing the GlobalMantix VLAN 10 subnet. This matches what our JSON dump revealed. In the next clip, we'll use RESTCONF to update the device configuration.